itself. So let me confirm once my screen is visible or not. Is it visible? Hello?
Yes, sir.
Okay. Any noise in audio?
No, sir.
Okay. So we can start. Uh, so today what we are going to discuss? Today we are going to discuss the type of miscibility. Okay. Okay. So let's say this is my mm, let's say this is my injection well and this is my production well. And this is my oil zone where I'm injecting this solvent. Solvent means gas only, which I want to inject. तो यहाँ पे क्या प्रोसेस हो रहा था? लेट सपोज कि यहाँ से जो ऑयल होगा, लेट सपोज वो यहाँ तक पहुँच गया है ट्रांसफर होते होते, और उसके बाद मेरा सॉल्वेंट है। ठीक है, ये मेरा क्या है? सॉल्वेंट है। और डेफिनेटली आफ्टर दी सॉल्वेंट आई हैव टू इंजेक्ट दी वॉट एवर वाटर इज I will inject, and this will water will drive this solvent and oil toward the production well. So I can say this is dry water also. Correct? So if this is dry water, uh, so we know that like whatever solvent we injected, it is miscible. It can be miscible with this oil as well as this water. Let's suppose if this concentration is not proper, then what we can say, this before reaching this oil at the production well, what happens? This solvent will exhaust and this water and oil will directly come into contact, and in that case what happen? It will not more miscible condition observed, and interference tension will again start to increase. So in that case we will not get proper oil recovery. So that is known as miscible rupture. So is it clear now? There is nothing too much to think. Any question related to this?
No, sir.
Okay. So everything is fine now, audio and my screen both, because I switched to my new tab, so I don't know how it's work. All functionality I is not active. Just give me quick confirm.
No, sir.
Okay. So let's start. So now I we reached to the injection of solvent stage. So now I can understand one thing from this, whatever I'm injecting, it what is how does it work? How miscible flooding is working? So it's simply what its functionality. It's miscible with oil. This is the basic functionality of this method. And what happen if this will miscible with oil? It will zero the interference tension. This we already know, because let's suppose if two phases are not in a distinguished phases, if they are in a single phase, then we can say there is a zero interference tension. But does it to direct miscible, does it how does it miscible with the oil? So anyone know that once I will inject the solvent inside the reservoir, does it directly miscible with oil or does it make initially any mass transfer or something kind of that? Have you studied this kind of stuff in any subject of in your course curriculum of BTech?
No, sir.
Okay, so we will start. So let's say first, so there are two kind of basically categorization of this method. So miscible flooding can be categorized in further two method. So the first method is the first contact miscible, and second method is the multi contact miscible. So by name itself, you can see it will miscible in first contact itself, and in second we can see it will miscible after multiple contact with oil. Okay, so we are going to study these things, but before moving to the actual methodology, let's I will give you the example of this like which solvent belong to which method. So let's suppose for a first contact miscible we have two substance, one is LPG and second one is alcohol. Uh, so alcohol is again important here, but you know cost of the alcohols, so they are very costly. So usually this is not that much suitable in terms of cost related issue. But LPG we can many reservoir are with like they already used in field, so you can get this kind of example or net or mostly this belong to America or something in that region only. So you can search on that regarding to this if you are interested in that. Next one is multi-contact miscible. So again, multi-contact miscible further divide into two another type. So let's say the first one is vaporization drive, and second one is the condensate drive. So again, from name itself, we can at least we can remember these things. Like in vaporization drive, we have a methane, and for a condensate drive, we have a intermediate component. Intermediate component means you can consider C2, C6, and second is CO2. Okay, let me confirm this. So regarding to gas condensate drive, you can use I think CO2 is a vaporization drive, and uh, these all belong to the all intermediate components such as C2, C6. So there are many cuts like it can be alkane, it can be alkene, it can be alkaline, or it can be mixture of those. So those or as belong to this category. So this is well sufficient. So you have to remember this thing. So this is important for us, like which substance belong to which category. Okay, they can ask question. So let's start the discussion with the first contact miscible. So now you all know the ternary diagram of a crude oil. So based on that, we can understand this all drive. So the first one we will start with, we can start with his first contact miscible. So let me ask you one thing. So let's suppose I have a crude oil which is a which has a components in which the percentage of my methane and ethane is higher, like it's around 60 to 70% in my crude oil is the methane and ethane, And let's suppose I'm injecting two solvent. One is let's say I'm injecting a butane and I'm injecting a propane. Then which solvent has a higher tendency to miscible easily? Can anyone answer?
Sir, I think propane will be
Yes, and what is the reason?
क्योंकि वो लाइटर कंपोनेंट है तो जल्दी मिक्स हो
Hmm.
जाएगा उसमें.
Yes. Okay. So it's correct. Like I already told you one rule regarding to miscibility. The components which are similar in nature. Similar in nature, that means they all are in similar in properties. They have a higher tendency to miscible with them only. Okay. So there are many exceptional cases like propane and all these may be exceptional cases, not propane, but they may have, because we know in chemistry we have a lots of exceptional cases, but this is the basic thumb rule. Okay, this may not work with halogen component or that kind of things, because mostly you, if you study 12th science chemistry again, then you can see most of the exceptional are from the halogen group only. So that may be not true for all cases, but we can understand. So in what happened in first contact miscible, so we know which two solvent we are going to inject, LPG and another one is alcohol, uh, alcohols. These two substance we can use, and how does it behave inside the reservoir? So we know this diagram. So while drawing this diagram, uh, just be caution regarding one thing. This is C1, then this must be C2, C4, and this is C7 plus. Then and then it belongs something like this. Else is it will change according to this axis values. Okay, and let's suppose this is my plate point. Now this is similar to critical point, so we know we can draw one critical line from here. Okay, so what we have? We have a liquid zone here, vapor zone here, liquid zone here, and liquid plus vapor zone here. And can anyone tell me what is LPG?
It's a liquefied petroleum. Yes.
Yeah, components, which is the major component of LPG.
I think sir butane are that major components.
Okay, it's a propane and butane. Okay, propane and butane are majorly in LPG. Uh, so let's suppose if I want to put my LPG in this ternary diagram, then where does it can belong? Can anyone guess? Not guess. Can anyone think logic? It's very simple. So we know this is 100% C7 plus this is 100% this and this is 100% this. So can you guess? Like it's not definitely it is not a exact location, but you can at least have idea where it where can I put that point for LPG in this case? It's very easy.
Near near
Oh,
C2 and
this is
C4.
yes, nearby this zone. So let's suppose this is my LPG. Actually, you can consider this as well, but let's consider any point of this. Okay. And let's suppose if I have oil with this zone only, uh, I can consider this is my, let's suppose I am saying this line is my critical line for now. This line is a critical line because this point is the P point is a plate point. So let's suppose I have a oil with this zone. Black dot is my oil. Okay, so this is my oil. Based on this composition, I can represent oil as a dot inside this ternary diagram. Okay, So let's suppose if I'm injecting this component inside my reservoir, so how does it behave? Okay, so let's suppose if this is my point A, or this line may be not exactly like this. We are considering very light oil here, uh, but that should not be the case. So let's suppose this is my line. थोड़ा इधर ले लेते हैं, ये वाला ए पॉइंट है यहाँ पे, ये यहाँ पे ए पे इंटरसेप्ट कर रही है. So this will miscible directly, like whenever I inject, once it will reach to this oil, so you can understand this is a miscible zone, correct? So here, once we inject this gas, so what process will occur here? So this C2C6 will directly miscible with the oil within a first contact. Like पहली बार मिले और प्यार हो गया, ठीक है? It's like that only. So nothing to think too much. So there is no any mass transfer involved in this process. So why it's not happening? Because let's say if you study the property of LPG, and let's suppose similar oil, if you observe, let's suppose if my oil belong to this, then it will directly go there and it can miscible with that oil, because this is vapor only, so that is also single phase only, so that is also miscible. But let's suppose my oil is inside something like this, then it might not, it has to go inside that two phase zone to miscible it, but that is not case here. So it should depend upon oil composition as well as LPG, because we are considering LPG, that means it's kind of a pure component. So this is the first contact miscible. Second thing is, let's suppose do you know, let's suppose I have a I'm talking about pure component, uh, I can say, let's suppose if I'm increasing my, simple phase diagram for a crude oil, this pressure versus temperature diagram, something like this. This is my critical point. Let's suppose I'm increasing C plus one. Oh, yeah. Let's suppose I'm increasing C7 plus concentration. That means I'm increasing C7 plus composition inside this crude oil. And anyhow, if I'm increasing C7 plus, that means I'm reducing someone, or that may be constant also. But let's suppose case, this is the case where C7 plus is lower, and this is the case where C7 plus is higher. So can anybody tell me how does this curve change?
Sir, the critical point will tends towards the left hand side of the curve in case of a C7 plus higher fraction.
Left hand side.
Means left hand side, yes. In a black oil or a volatile oil side.
Toward this side. Are you, do you want to tell like this? This is, let's suppose previous one is
Yes,
this one, then this will shift toward this.
yes, sir.
While increasing C7 plus. No, it's not true. It will
नो सर, वो राइट साइड आएगा और नीचे की तरफ
Your voice is breaking. Can you repeat?
वो मतलब वो सर क्रिटिकल पॉइंट राइट साइड तरफ जाएगा और थोड़ा नीचे की तरफ होगा.
Yes, yes. So the curve will shift toward the x-axis. You can say like that. Okay. So this curve will shift toward x-axis. Let's suppose this is curve, then this will again, yeah. So let's suppose if this is curve, then this will shift toward right and little bit lower. That means this curve entirely shift toward this x-axis. Okay, like this. So now critical point is somewhere here. So you can think right now, it will come like this. Okay, so let's say what's happening in this case, this critical like x, this, okay, curve. wave towards x-axis. So you can say what is impact on pressure, like when C7 plus is higher, critical pressure is reducing and critical temperature is increasing. Okay. So same way, this is, you should remember, this can directly, it can be a MSQ for your next gate or for any upcoming gate. And one more thing here, let's suppose this concentration is increasing, that means this A point is shift towards upward side. Okay. Because let's suppose this C1 is increasing or that, then it will go toward that side only, because this is the critical line. Okay, let me draw critical line once again. It should be start from oil only, not like this. Let's suppose if this is my oil, uh, I'm considering the last case. Again, I, I choose wrong pen. Let's suppose this is my oil, which is on this critical line. Okay, consider the case where this oil is on my critical line. Okay, and let's suppose this, I'm increasing the concentration of C1, then definitely this line will shift toward that side, because this line is representing the percent, like whatever here we can understand. If this is let's suppose this is 70% C1, then this can be 80% of C1. So that line will shift toward C1 side, a critical line. So what is condition necessary here? My oil must be uh, compatible compatible with this critical line, and it should be like LPG will directly mix at the first contact only. And so what condition I can define here is, let's write here, condition to obtain first contact miscible. So whatever line I'm drawing, OA, it should be a tangent line. Okay, maximum tangent to two-phase zone. Okay, I can say in that way also, this should be a tangent line to this curve, this critical point. Okay, from this point it must be a tangent line. So OA is a अरे यार, something wrong happened here. Okay, so this is the condition for this first contact visibility, and it will never going to cross that two-phase region. So every time it will attend that first contact visible condition only while we are injecting alcohol or we injecting the LPG. Okay, so let's suppose, so what are the conditions required here for LPG? So slug has the lower C1, because we are saying, let's suppose if slug should have lower C1, because we understand that miscibility will obtain with similar compositions easily. So like we are injecting the butane propane level of component, then low that all other components like C7 plus should not be present in higher quantity. So oil must be rich in, what can I say? Oil should rich in intermediate component. These two conditions are basic definition for first contact miscibility. Now, once you understood this, let me know if any doubts in this case. like what is first contact miscible? Like it's very simple. You are injecting the solvent in at the first contact itself. It will miscible with oil. There is no any mass transfer necessary to do the to attend this miscible condition. And this occurs when you have a similar composition to LPG in your crude oil, which are basically intermediate components such as butane and propane. Third thing, like your oil must be live. You're in such a way that that line from your that line which is the maximum tangent of from that two-phase John curve. These three are most condition, and while increasing the C1 composition, uh, let's suppose if your A point is in such a way that, let's suppose if this is your A point, this is your A point, then oil will pass through this two-phase zone. Okay, so in that case, here you won't get that miscibility. So this OA line must be outside of that zone only. Then and then you will achieve the miscibility here. Okay. So which zone? This zone is suitable for LPG. Your crude oil must lie in this zone only. Okay. So this A is a LPG. Okay, it's not a mixture of this. Don't confuse with this A. A is a what you are injecting. It is a solvent itself. So this is not LPG. Okay, this is just considered as an intermediate component only. This is the zone where you are this going to dissolve. So it can be lie here, it can be lie here, it can be lie here, it can be lie here. So that all composition uh, may vary in LPG also. Now LPG is again not a pure propane. There are impurities present. So based on that, you can decide that point. It can be anywhere from this. So if let's but maximum condition is which? Maximum condition is maximum tangent line from this two-phase zone. So above this A point, you won't get first contact miscible because it will start to pass through this two-phase zone. So definitely your point must be the minimum condition required is maximum tangent line from that two-phase zone. So any doubt in this? So don't confuse, like initially we decided it belong to this, but let's suppose if it is a like impurities are present, then it can lie here, it can lie here. That totally depend of composition and purity of LPG. So A is again a solvent itself here, but this is this is the explanation for maximum like condition which required condition to explain this first contact miscible. So any doubt in this?
No,
No,
sir.
sir.
Same impact you can think with C7 plus also. Let's suppose you are increasing C7 plus, then again, let's suppose your oil may come to here. Your oil may come to here. In that case, again, let's suppose if I will draw line with this A point, let's suppose I'm considering this A point as my solvent, then it will again pass through that zone, two-phase zone. So just think from this diagram only, it will give you all ideas. So now you can understand in which condition. So I have marked the cross for this zone. Okay, so this is if my A is a solvent, or it can be belong to this zone. But here we are injecting LPG. Okay, we are not injecting intermediate component. So LPG means higher in propane. It should not like 30% propane और हम उसको LPG बोल रहा है. It should be 80 to 90% are propane or butane only. So in that case only you will get the first contact miscible. So if this is clear, then we can move to the next one, which is a condensate gas. Which is the multi-contact miscibility. So any question from your side or any else? Any doubts?
means, sir, the when the line must be tangent to that two-faced region.
Yes, line like minimum condition, like
I-
where let's suppose let me explain this from another diagram. Let's suppose this is my two-phase zone, okay, and this is my plate point, okay, and my oil is here, let's suppose, and I'm injecting this A, okay. So what's happening here? Let's suppose if I will connect these two, because what happened once this come into contact, ओके, तो ये ऐसे कांटेक्ट में आएंगे, ठीक है, ये दोनों के कंपोजिशन ऐसे नहीं बन सकता कभी, ठीक है, ये ऐसे जा नहीं सकता. That should be a long process which we will discuss. Let's suppose in this case also miscibility can be occurred, but it should not be at a first contact. Let's suppose first contact में जब ये दोनों मिल रहे, ठीक है, तो तभी क्या हो रहा है, फर्स्ट कांटेक्ट में जब ये मिल रहा है तब ये कंप्लीटली मिसिबल नहीं हो रहे, इट्स पासिंग फ्रॉम टू फेज जोन. ओके, सो आई कांट से करेक्टली कि ये फर्स्ट कांटेक्ट में मिसिबल हो रहा है, ओके, बट लेट्स सपोज माय ए पॉइंट इज हियर, सो आई कैन से फर्स्ट कांटेक्ट में ही दिस कैन बी मिसिबल.
Okay, sir.
So based on this, you can say this is a first contact miscibility. This is not a first contact miscibility. So if it is not a first contact miscibility, so it can be either a multiple contact miscibility. Okay. Or
Okay, sir.
so the minimum point of A, like minimum distance from C1 required to be a first contact miscible is a distance where if I will draw the tangent line from this oil, so it should be a maximum distance from this, like a minimum distance required from C1 to this A point is the maximum tangent line of from this plate point and this oil. Okay, understood?
Yes, sir.
After this A, let me do one thing. ये बहुत चिपक रहा है अभी वाला जो, ठीक है. Okay, so now we can move to the next topic, multi-contact miscible. So let's suppose if these kind of conditions may happens because of composition of crude oil and whatever solvent we are injecting. So in this case, how does it miscible? What process occurs here in case of multiple contact miscible? So we already categorize this into two parts. So we know the first one is, let me do one thing. Let me stop my screen and I will share this again. So is it visible now?
Yes, sir.
Okay, but still it's, so the first one is a vaporization drive. Second one is a condensate dry. So this is like after this session, it is very easy to remember, but it is, I think it is a hard to explain. So make sure your concentration is here. It's not hard to understand, but let's say, let's suppose if we are injecting, so let's start discussion with first one, vaporization, right? Okay, so what is in case of vaporization drive? Uh, what we are injecting here, light components such as the natural gas or enriched natural gas or flue gases such as N2, CO2, methane, or not enriched gases. Okay, enriched gases mean intermediate gases. So we can say this kind of light component if we are injecting. So what is the process occur? What kind of process occurs in that case? So we are discussing here vaporization drive. So let's say this is my ternary diagram. Let's say this is my C1, this is my C2, C6, and this is my C7 plus. And let's suppose if my diagram is something like this, and this is my plate point, and what we are injecting, let's suppose we are injecting this C1, let's suppose we are injecting pure methane. So it lies on this point only. We are injecting C1 inside this. And let's suppose if this is my critical line and this is my plate point, and let's suppose if this is my oil, what is this is my oil. So I will represent this with oil, and this is the point C where I'm injecting the methane inside. And we know at first contact it will not that miscible directly, because we know it will pass through this zone. Okay, so I'm not able to draw perfect straight line. Okay, that's it. So this is two-phase zone, so it's already passing through that. So at a first contact, it is not a miscible with oil. So methane is not miscible with the oil. Or let's suppose if it is a N2, then it will not directly miscible with oil. So what kind of process happens here? First things required here is, let's suppose if my crude oil is uh, so first condition required in this case is, so the I think I have to, something glitch happening because I'm not able to draw it properly. Mm, guys, just wait for a 5 minutes. Mm, Milind, just stop recording for a 5 minutes. You can start it
Okay,
again.
sir.
And I will join once I will resolve this issue.